All right, here we go. So again, we are still in chapter 4. Which is exponential and logarithmic functions. Today, we're going to focus on section 4.2, which is just exponential functions. I'm hoping it's real quick and easy. Should be more of a review than something new or anything from pre-cal. This is more of an algebra 1 term that we went a little bit more in algebra 2. I don't even know if we really even focus on it in pre-cal as much as just the basics. All right, objective 1. We'll be graphing exponential functions. I think there's only 3 objectives. That's an E. Exponential functions. All right. Graphing exponential functions. Oh, I don't think I spelt it all the way right. Hold on. Let me try that again. I got distracted. Yeah, I did. All right, let's do that again. So exponential. There we go. Huh? Oh, I guess so. I don't like text box. All right, here we go. So here's our first question. It states graph the functions and write the domain in interval notation. So we're going to graph the function. And then write domain and range in interval notation, which again is the parentheses and brackets and the unions and all that stuff. All right, here we go. So here's our first example. We have g of x equals 4 to the power of x. So exponential functions are where the x is the exponent. A couple of reminders. Our parent function is y equals a times b to the power of x. A is your y-intercept, which is your starting value. B is your growth or decay of the function. If B is greater than 1, it will be a growth. If B is between 0 and 1, it will be a decay. Right. I guess I should be more specific. It should be greater than or equal to 1 because if it's 1 in itself, it is still a decay, growth. Actually, I lied. If it's 1, it's not an exponential function at all. Yeah, so if B ends up equaling 1, you just have a constant line because you're just multiplying by 1 every time and it's never changing. All right, so if it's greater than 1, it is a growth. If it's between 0 and 1, it is a decay. Hopefully that's kind of rejogging some memories there. So to graph this, just identify your A and your B. What's my A? 1. There's no number there, so there's an imaginary 1 there. So it's like 1 times 4 to the power of x. And then what's my B? 4. So is that a growth or a decay? Growth. I don't know how specific your homework is going to make you get, but this is what I'm looking for. I want you to plot the y-intercept. So I want to see it like this. And then knowing that it's a growth, it needs to be shooting up. So what's going to happen is there will be a horizontal asymptote at y equals 0. And so you should see a line that kind of follows that and then gradually goes up. All right. What I'm most likely thinking is they're probably going to have you write 2 or 3 points, plot them. Simply just plug in 1, you get 4, plug in 2, you get 16, and then you'll be able to graph the function. Just like in the last section, there's probably a branch function that you can just plug in there. 1, yeah. That's the y-intercept. And then after that, just knowing it's a growth, I know it's going to look like that. Any questions? Yeah, that's pretty much it. Right, if it was a decay, I would start way up on the infinity side and come down and gradually go down. So just an idea, a growth looks like this, and a decay would look like this. Ah, okay, maybe I should start it there. Again, just don't think I want to make sure. Oh, well, yeah, I'm just making sure I haven't finished the graphing. Yeah, it looks like in y'all's homework, it's just making you plot 2 or 3 points to get an idea. Other than that, that's really all I'm looking for. Y-intercept in the correct direction of growth and decay, and I'm happy. Right? Other than that, yep. All right, so then domain and range. Domain of all exponential functions. As you can see, if I plug in any x value, I will get some type of y value out of it. So that's going to be negative infinity to infinity. Your range is going to be different. If it's above the x-axis, then you're going to see that it's going to be 0 to infinity. And if it's below the x-axis, which does happen, if the a is negative, then it'll be negative infinity to 0. So in this situation, what's our range? 0 to infinity. But what will the 0 get? Parentheses, because if there's a horizontal asymptote right here that the line will not cross, they'll never actually equal 0. Questions on domain and range? All right. Let's do another one. Let's choose a different color. Let's go with red. All right, number 2. Let's look at k of x equals 1/4 x. I'll give you an opportunity to try to graph it before I go into it. All right, do we all have a idea of the answer? All right, what's my A? 1, good. What's my B? 1/4. So is that a growth or decay? Decay, very good. So what I want to see is a point at 1, and then you can just kind of sketch a decay like that. And again, on your homework, you'll probably have to plug in a couple of numbers and then just hit the branch button and it'll make it. Also on your homework, they might make you with that horizontal asymptote at y equals 0. Right now, that's what it is. It's about to change here in a second. But we understand the basics of exponential functions. Okay. Yes, ma'am. This arrow here, it just goes on. It comes from the infinity sign and then comes down, because basically what this is stating is that you have a really big number, and if as it's decaying, it's just getting smaller and smaller. In the real world situation, you wouldn't even see that part of the graph. It would just start there and then progressively go down. And it's actually going to be a quarter. So from 1, it shrinks by a quarter each time. So that'd be a quarter, a 16th, a 256th, and then so on and so on and so on. Nope, that's too big. A 1/64th, then 256, and then so on and so on and so on. All right. So then the third example, we'll talk about a few things. Let's see if they got a cleaner version of what I'm about to write. All right, so let's just kind of use a generic. They don't have a really good one. Let's call this, say that we have an A times our B, our normal stuff. But now we have a X minus an H plus a K. Okay. So if you recall, from all our other parent functions. The minus h does what? What did it do? Left or right. So if it's a negative h, I went where? Right. Remember, it did the opposite. So same concept applies. If I had a positive h, I go where? Left. Very good. And then the k dealt with what? And that would be the a. Remember, the a is still your y-intercept, and your b is the your growth or decay. That doesn't change, but that would be the up or down. Yes. So if I had a positive k, I went what? Up. And if I had a negative k, I did what? Down. Good. So that part doesn't change, just like in our other parent functions that we did in what, unit 2 or something like that. So same process. All right. So if I give you an example like this, q of x equals 4 raised to the x plus 1 plus 2. Okay. Give you an opportunity to write that down. It is. Was it? A weird 3? Okay. No, there's no 3. Okay. All right, so there we go. So to start this off, this guy right here is going to affect my horizontal asymptote. So when I say plus 2, that I know I'm going up. So instead of a horizontal asymptote at y equals 0, that now means I have a horizontal asymptote at y equals 2. All right. This plus 1 does tell me I need to go left. So this is how I kind of want you to think about it. What's my y-intercept? 1. Right? That's still my b. So it's still going to be a growth. So my b would be 4, which tells me it's a growth. So if my y-intercept was, where are we at? Right here. Sorry, there we go. And then I shift it up 2. So now I'm at 3. So you kind of want to start where your y-intercept is. The plus 2 shifts you up 2. So it also shifted up the y-intercept. But then the plus 1 then does what? Moves it to the left. So there is my new y-intercept. I know it's kind of crazy to think of that, but that's kind of like your starting value. So you're originally at 1. The plus 2 moved you up 2. And then the plus 1 moved you here. So you have a coordinate that's very specific, -1, 3. After that, all I care about is, all right, it's a growth. So it should look something like this. Yeah. Yeah. If you plugged in 0 into that equation, you would get 6, right? Yep. You would get 6. Because 0 plus 1 is 1, 4 to the first power plus 2 is 6. So if I want it to be real accurate, I should have shot up a little bit further up into 6. But that's probably what your homework's going to want you to do. Here, I'm happy there, right? I want to see that specific point that's being moved. Make sure your growth or decay is obvious in any horizontal asymptotes. Okay. Questions on that? Yep. Go ahead. Ask a question. Nope, I did not. Okay. The domain is what? Infinity, infinity. That part won't change. The range does change a little bit. What is my range in this case? Good. 2 in parentheses to infinity. All right. So instead of 0 to infinity, because the horizontal asymptote moved up, is now 2 to infinity. Right? Any question there? All righty. So I think that should take care of objective 1. So is there any questions on how to graph exponential functions? All right. Let's move on to objective 2. I need a different color. Let's go with this new orange. Orange it is. I don't know. Objective 2. We're now going to talk about evaluating, which is my favorite part because it gets us away from graphing. You know, as a student, I never enjoyed it. And I feel like even as a teacher, I still don't enjoy graphing. But evaluating, oh man, I can do that all day. So evaluate the exponential function base E. E is not a variable. E is a value. My memory serves me right. It's like 2.7 or something like that. Let's see. What is it? A lowercase e. Lowercase e. Yep, 2.718 something. All right, just like pi, we got 3.14. E is like 2.7. It's actually both pi and e come from calculus using limits and protein and stuff that you've kind of gotten a little feel of that allows us to get to these actual answers, right? But e is just an actual number. So let's see. So in our fourth example, we have g of x equals e to the x minus 2. All right. And this is not evaluating. Part A wants us to graph using our evaluation rules. And just so you know, a y equals e to the x, e being 2.7, would that be a growth or decay? Growth, where's the y-intercept? 1, because there's an imaginary 1. So this is what this guy would look like, right? So that is what y equals e to the x looks like. It's a growth that starts at 1 and then just increases by 2.7. All right, so we're going to use that concept to help us kind of graph this first one. So what's this minus 2 going to tell me to do? It's going to go to the right. So when I graph this, my y-intercept would be what? It would start where? It would start at 1, but then the right tells me to do what? So then I need to go right 2. So now my y-intercept or my starting value is now at 2, comma 1. And if you think about it, that makes sense. If you plug in 2, what's 2 minus 2? What's e to the 0? Anything to the 0 power is what? 1. So e to the 0 will be 1, which is where we landed. All right. My horizontal asymptote did not move. I just moved it over. So I would technically still have a horizontal asymptote right there at y equals 0. Yes. 2.71 something. It's like pi. It's an actual value. So the fact that 2.7 is greater than 1, that tells me it's a growth, right? Oh, that's not something I want to get into in this class. Maybe after we get done with our semester final, we can talk about it. So it's like pi being 3.14. E is like 2.71. It's an irrational number. So it keeps on going with no actual pattern. Irrational meaning the decimal doesn't end and doesn't repeat. Back in unit 1. All right, so there we go. So we kind of somewhat graphed it. So again, knowing that this is a growth, I should get something. I don't want to get something like that. All right, there you go. So again, now I should specifically see that point that I went through. Again, on your homework, I'm sure they're going to make you plug in some other numbers. You just plug them in and calculate where it's at, pull up the range. And again, they're probably going to want you to do the horizontal asymptote, right? Just like in the other previous homeworks. Any questions on that? All right, part B. It wants us to write the domain and range. What's the domain of this guy? Negative infinity to infinity. Perfect. What's the range? Good. Parentheses around both. Very good. Any questions on domain and range? All right. Part C, which is the last part. It says write an equation of the asymptote. So what asymptotes do I have? It'd be a horizontal asymptote, but how do we write it? Y equals 0. I will say that on the test, some on the axis symmetry just said axis symmetry equals something. Remember, it was x equals an equation. Okay. Any questions there? Some really good. And I don't even know if they've missed one. Some, and then some. It's a good range right now, but I'm about halfway done. I haven't actually fully graded any of them. I've only made it to question. I'm at the upper and lower bound. Oh, yeah. And that's where I realized I made the mistake, because then I went 6 plus 7 is 11, and y'all all wrote 13. And I kept circling all of them. And I was like, why are y'all all getting the same answer? Before I realized, because 6 plus 7 is 13. But I don't think it affects the answer any. But we'll get, it's all right. I will talk about it later. All right, any questions on that? All right, and that's pretty much it on objective 2. Even though it says evaluate, we didn't evaluate nothing. All right. Well, I guess there is some examples that didn't have us do it. If you had to do this evaluating part, you're gonna have to do it with a calculator. So as long as those calculators has an E on it, which I believe they do. I do not have any here. Well, I don't have a letter E. Oh, I do. I see it right there. So it would be second natural log. So if I ask you to find if f of x equals e to the x, and I ask you to find f of 4, you just plug in 4 to the x. So you would figure out what e to the 4th power is by doing control natural log. E will pop up, type in a 4, and there's your answer. Right, that's it on that. If we need to go over those, we can. I want to make sure I catch the rest of it. All right, last objective. So objective 3. Yes, these are word problems. Use exponential functions to compute compound interest. We got any business majors? Welcome to business calculus. All righty, here we go. So here is example 5. That's a lot of writing. If I can get my pen right. All right, so here we go. So suppose that 8,000 is invested at 3.5% interest for 20 years under the following compounding options. And it's basically just asking you to complete the table. So part A, annually. Part B, quarterly. Quarter. Nope, not spelling that right. Let's try that again. Whoa. It deleted some things. Let's try that again. Okay, there we go. Monthly. Apparently have two C's. There you go. They were B's. And I'm saying C. My brain is somewhere. I don't know where it's at, guys. Maybe I'll find it later. All right, my D is daily. And then your last one, E, will be continuously. I thought we were heading that way too. B is quarterly. That's a Q, a U, an A. Oh, that's just making it worse. I'm going to blame technology. The C is monthly. Oh, because it looks like a K. Quarterly. Monthly. Okay. All right, here we go. So, a couple of things we need to write down as some notes is your business equation. No. I don't want to. Okay. Yeah, I'll make this a PDF. Yeah. I'll always do that for you. Until your hand gets better. All right, so here's the formula you need to know. There's two equations. Okay, one, let's do some reminders. We had simple interest, which was I per. So I equals P, I capital P. This is what we learned in the first unit. You won't need it here. The next one you need to know is this guy, which is A equals P times 1 plus R raised over N raised to the NT. I will not make you memorize that. I will supply it for you. That's P times 1, not a 3. I know it looks like a 3, but it's a 1. Plus R divided by N raised to the N times T. I will not make you memorize this because even in the business world, they just expect you to know how to use it. All right. Now this works. One more time. That's an A. Yes. Not a 2. All right. So there's your equation. The other equation you need to use, and you only use it if it is continuously. So continuous. Go away. So continuous. Where's how you spell the word continuous? I think that's how you spell it. Continuous interest will be A PERT. A equals P times E raised to the RT. I won't make you memorize that one either. So the middle equation we'll use if we have a certain situation where it tells us it's annually, semi, quarterly, monthly, daily, hourly, whatever the situation is. But if it is a continuous, we will use E. So that would be A equals P times E to the RT. Now, here's a couple of things. P represents principal. That's the beginning. Prince, maybe? I don't know. I get the idea. So P is principal. R is the rate. Remember, you got to turn that percent into a decimal by moving the decimal place 2 times to the left. N is the number of, how they want to write that, periods. And I'll explain that here in a second. And then T, of course, is time. Oh, yeah, sure. A is the actual amount, like your total amount at the end. All right, so to break this part up, first thing I want to talk about is just how many periods are there. So what is my N, which again is periods. So if it happens annually, how many times do I interest? Nope. What? Oh, no. Just in general. If it's annually, what is it? Once. All right. So my N here would be 1. Quarterly, how many times does that happen? 4. So my N would be 4. Monthly, 12. Daily, we'll use 365. We will not account for leap year. All right, so we will just say it's 365. And the continuous, there is no N because we would end up using a PERT. Okay. All right, so that takes care of that. So now we're just going to actually work it out. So let me do this in a different color. So to separate it, this is a weird looking green. I'm trying to get it all on one page. I can't zoom. Okay, I'll do another page. Part A was annually. And our N was equal to 1. Our equation was A equals P times 1 plus R over N. You can't see that? Oh, my goodness. You write it over here. Stupid board. No, it's fine. It's the board. This is your equation. I don't expect you to memorize it. What happened? What did I say? Oh, okay. So I'm going to plug it into this equation. Now this is where we use the information that you had already written down. Forget where I'm at. So that would be C. So our P, so A equals our principal. What was our starting amount? 8,000. So my P would be 8,000 for future reference. So it'd be 8,000 times 1 plus what's my rate? Good. It was 3.5%, which now becomes 0.035. So that becomes 0.035. What was my N? 1. So it happened one time in a period. By the way, when you talk about credit cards, this is where APR comes in. APR is daily. You get a daily interest rate of 26.44% on your basic credit cards. Just to think about that. Same thing with your house and your car. When they talk about APR, you're getting interest daily. Right? But you're not going to get hit with 26.5% daily. It'll be 26.5% turned into a decimal. So that's 0.2655 divided by 365. So then that's the interest that you'll be hit every time. So it ends up being like, I don't know, like 0.0003% or something like that. But that's something that's occurring daily. So like when you put a credit card swipe and you don't pay it off by the time the 30-day period ends for you to pay it off, then it goes from that 30-day period and it counts interest for each one of those days and tax it on to your credit card. That's how that works. Unless you pay it off beforehand, then it's free money because it's borrowed money that you paid off. So where's my NT? So that would just be 1. And what was my time? 20. Because it said for 20 years. All right. This is where those calculators will come in handy just to do simple math. I say simple, a little bit more complex math. So let's see. So we got 8,000. This will end up being 1.035 raised to the 20th power. That's a big number. So let's get our handy dandy calculators out. I can't display this. So we got, I would do 1.03, turn the calculator on would be your first step. on, which is on the bottom left-hand corner. Mine has A, B, C, D, E. I'm just going to clear everything. And then it's going to be 1.035 rooftop 20. You get some long decimal. Just hit the times button and it'll take that answer. So you don't have to worry about rounding errors. Times 8,000. And we're going to round that to money. So that's going to be 2 decimal places. So that looks like that is $15,918.31. Right? So there's part A. Part B, I think this is our last question too. No, there's one more. There's another adjective. Yeah, there's another word problem type. So there's 4 objectives. I thought that was all one. All right, our quarterly, we learned our end was quarterly. I gotta say quarterly right, and I'll remember the ER. Is 4. So I'm just gonna do the same thing. I'm gonna plug in all that stuff. I'm gonna use a different crayon. Someone said that this looks like a crown color. It does not look like much difference. This looks like peas that you eat and squish up. Yep. Divide that by 4 this time. So now you're not getting hit by 3.5%. You're getting 3.5% divided by 4 every 3 months, because that's what quarterly is. So then that would just be 4 times 20. That's every 3 months. It's quarterly. Yeah, if you do 12 divided by 4, that's 3. So every 3 months, you would get hit with that charge. Yeah. A lot of the way your interest works is they'll say, yeah, it might be like quarterly, but if you pay off the balance before that quarter hits, you don't get hit with a charge. It's if you go past that day, then they backtrack and use every day as against you. So that's how you can use credit cards, by the way. Life stuff. All right, let's figure out what this number is. So it is 0.035 divided by 4 plus 1. Don't round, be as accurate as you can. So 1.00875 raised to the 80th power. And again, since you already have the number, if you just hit rooftop, it'll take the previous answer. Type in 80, you get a weird number. Hit times, again, it'll take the previous answer. Multiply that by 8,000. I suggest these things so that you don't have any rounding errors. You don't want to round until your final answer. So use all those long decimals. Don't worry about typing them. Just hit the command so it uses the previous answer. In this situation, we get $16,061, and it looks like that's a comma. Should be a decimal. 5 cents. So notice annually. Now I don't know if this guy it's being worked for him. He invested. So this is how much money he made. So when it was annual, he made, roughly 7,000. Here now he's almost made 8,000. He's doubled his money, and that's just going quarterly. So let's see what happens with the rest of it. C was monthly, which we saw was N equals 12. I need a different color because it's going to blend in. Pink. All right, going back to pink. So that's a eraser. All right, so this time we get A equals 8,000 times 1 plus 0.035 divided by 12 raised to the 12 times 20. We work this magic out. Okay, so again, that's going to be 0.035 divided by 12 plus 1. I'm going to have some rounding going on. Well, no, I won't. I'll have it rounded on my paper, but I won't actually round. There's more numbers past that, but it's okay. 12 times 20 is 240. So again, with that long decimal there, just hit the rooftop so it takes that previous result with no rounding errors. Type in 240, get a number, multiply that by 8,000. Again, it'll take the previous answer. Not much of a difference. Oh, like 150? Yeah. So this would actually be, yeah, it's 240. I got a dad joke. I made a pot of beans the other night, and I made sure there was 239 beans. So I didn't want it to be 240. Get it? Because it's beans in it. Okay. Anyways, you're welcome. I'm here all night. So it's 16,000, $93.62. That's going from quarterly to monthly. So this is once a month. Part D now tells us to do daily, which we saw that daily, the business world sees it how? How many days is daily? 365. We do not account for leap year. I need a different color. Let's go with blue. Huh? Right, but actually it's less than that. So that's why our time changes so much on day and night. Um, it's actually like I don't know, I think it's like 0.24 something. So it's like less than a quarter, but by the time you notice, it's gonna be like 100 years, and it's gonna be like 2, 3, 4, 5 minutes, something like that. Hmm. It brings in those extra days, but it's the minutes. And you'll get to a point where you eventually it's like it's daylight like at 5 o'clock, but it won't be in y'all's time. Oh, they adjust it? Oh, I didn't know that. That's cool. It does? I did not know that. I wonder how they adjusted it. It'll be like 100 years. It'd be like 5 minutes. Like you won't even notice it. Hmm. All right. So when we do this right here, let's see. So we get a 365 times 20. I got lazy there, guys. I feel like writing it all out. But that's going to be 7,300. All right, so there we go. So we got 0.035 divided by 365 plus 1 raised to the 7,300th power. Ooh, calculator went slow on that one. Times 8,000. All right, then much different on this one either. So that would give us 16,109.48 cents. Part E. Huh? Oh, yeah, sorry. It's like 2 point. No, it's not. It's like 1 point something. It's like 1.00 number. It did. When I just raised it to the 7,300 power, it took it 2 seconds. So it went. Oh, you make those lag real easily. All right, anyways, so to work on the continuously part, we're going to use the equation A PERT. So that would be A equals P times E raised to the RT. So in this case, that would be 8,000 times E raised to the 0.035 times 20. All right, so here we go. So the way I would do this, I would do 0.035 times 20, get that exponent, which is 0.7. And then I would do second ln, which represents natural log, and e to the rooftop of a parentheses will appear. Type in that 0.7 that you just calculated. Hit enter, you get some decimal. Then multiply that by 8,000, and there's your answer. It'd be 16,110 and 2 cents. Yep, there you go. Yeah, not even $1. So you can see that continuously and daily is pretty darn close. What time we get out of this class? On Mondays? 46, 49, 47. So I got 3 minutes. I'm going to run down this last word problem. It's actually a lot easier than this part. Ready? Okay, let's go fast. Objective 4, use exponential functions in applications. I'm not going to make you write this entire word problem, but in just, it's going to give you a long word problem talking about something random. It's going to give you an equation though. You write that equation down. So in this case, this would be what the long equation is. Function in, sorry, that's an IN. 138.4. So it's an idea. It says in 2006, the murder of Alexander Litvinenko, a Russian descendant, was thought to be poisoning, by poisoning from the rare and highly radioactive element polonium-210. The half-life of that is 138.4 years. If 0.1 milligrams of this is represented in a sample, then they give you the equation. Gives the amount A of T present after T years, and then he wants you to evaluate the function for the given values of T and interpret the meaning and context. So all you have to do is they give you a whole bunch of information. Just find the problem, the equation, and then it's going to give you parts. So in part A, it's going to say find A of 138.4. Right? That one's actually easy because that gives you 0.1 to the 1/2 times 138.4 divided by 138.4, which will give you 1. So that's 0.1 times 1/2 raised to the 1. 1 to anything is the same. So what's half of 0.1? 0.05. Right? But you can use a calculator for that. And so that one's real easy. Then it's going to give you another part. It'll ask you to find like A of 276.8, which actually is double that. So just an interpretation, that would be, and I guess that's the bell there, but that would be like, that's what it is left in half a year. That's a half life. Yeah, you just plug it in. That's all you do. And that's it. That's the end of the notes. So again, that homework's already opened. I think it opened last week, maybe. I think so. But it's due on Thursday.